Boom. We're live. Hello, world. My name is Alan. We're practicing LeetCode live. And I also called it LeetCode on a Folk. So we're doing this hard level problem. It's called Basic Calculator. And this is part 2 to the part 1, which I did not record, but I just decided, let's see if I can have some progress after the part 1 and do it live. And so let's recap what has been done. And because turns out I read the description well, but not good enough. So throughout the solution, I was thinking, well, let me go through the description here. So we need to calculate the result for a math expression, and there is only pluses and minuses and parentheses. There is no multiplication division. So there is plus, minus, paren, and there are also spaces. But so the expression is, I don't know what, is given in a string. No, okay. The expression comes as a string with these symbols, these characters. S could be the length of, oh wow, it could be pretty lengthy expression. So we'd better do it in a linear fashion, because 10 to 5. Because 10 to 5, what I know so far, the topics are math, string, and stack, and recursion. I haven't found, I'm still curious about the recursion part of it. I mean, how I would solve it, how I would use the recursion here. I like recursion. But so far I found a way to use stack here, which is pretty common. That's the word for expressions like these. The most general case that I know to solve the math expressions when you have all the operations is to transform this expression, this infix, where the operator is inside, so between the operands, is to convert that into a polish. It's called a reverse notation, reverse polish notation, I think. And that notation is, if I'm not mistaken, reverse polish notation. Reverse. That looks, when you use that, you have in a reverse polish notation, I think it's postfix, right? Yeah. So you have the numbers first and then the operations. The typical, yes, I'm just giving a little background to, like, I don't know, to get to my solution. A little background. Pretext. A reason given and justification of a course that is not the real reason. Pretext. So I'm learning some words along the way. Oh, pretext. Okay. So the most general case could be solved with turning into this reverse notation and then using that reverse notation, reading from it, getting your expression. In this case, I was like, and sometimes you don't have to use it. You do this double conversion, and in this case, it's SPACY calculator. It's simplified, so there is no multiplication, but there is parentheses, and that's the whole game. Yeah, here is the parenthesis, because without the parenthesis, it would be just add this plus that minus this minus that. So there would be no group operation. It would be just, you can go and just add one to another. One of these parts, add one number to another number. Yeah. Or deduct it, whatever the operation is. But since you have parentheses, that means you need to finish the calculation within these parens, and after that, apply the operation in front of it, which could be negative, could be minus, so you can already see that, yeah, it's kind of recursive. But I tried the iterative solution first, using a stack. A stack would help you stack things up and get back to them later, which is what you needs to be doing as you go through this expression from left to right. You don't know what to do with this one until you solve this. This nested expression. So I kind of solved it, I think. The only problem left is I solved it for digits, not full numbers. I was like, because I read this, it consists of digits and these characters, so I thought, like, okay, all the numbers are just one digits, and that was my wishful thinking. But I had this at some point. I was like, what are the actual numbers? Are they just one digit or they're bigger? But then when I ran the code and I bumped into a test case that was obviously a bigger number, then I looked again at this constraint that was like every number in running calculation will fit in a signed 32-bit integer. So yeah, I was thinking about the running calculation. That's how I was reading, in a running way. I wasn't detailed enough. I think that's one of the lessons. You got to be really, really detailed in reading the descriptions, the problem descriptions, because problem statement. Because you see this, every number could also be. And what is signed? Signed means it could be positive and negative. So there is a sign in front of it. But it could be either, could be, and so it could be a big number. Every number could be pretty big. And 32 is like, is like nine digits in 10 to 9 with a 10 based numeric system. So I need to teach that that code to so yeah, so 10 minutes to if like of some background, and now we have this code. What it does is we have two stacks, operations and numbers, ops and nums, and we go through the string, through the expression. Essentially, this is the loop through the expression, and at the end we return the top, the stack nums, the number that's on top of it. It should be the one left, the only one left. But we also have this function that essentially just takes two numbers and just if the second one is negative, so if the operation is minus, then it's just it does the minus operation. Yeah, so it changes the sign for this B number. And so it's our number A, number B, and the operation plus or minus. Yeah, that's what it does. And it does the calculation. And this loop, it has this switch case. The entire loop is this switch case. So we have some kind of character. And if it's a space, we skip. If it's an open bracket, we also skip, which I'm not sure that it actually works yet. But that's how it is. And I think it actually works on a lot of test cases. Yeah, it went wrong on the 8th test case, but on a multiple of, yeah, it worked. By the way, we can actually, I just remembered that we can create a test case of our own. Like I wanted to test this -1. Like what will it do with -1? Will it do right? Yeah, got an index out of range on -1. Yeah, we definitely need to fix. Okay, that's another problem. But test cases, I want to also have this. I also want to have this. Yeah, it hits this out of range when we try to get something from nums. Well, it's obviously there's nothing on the nums. Oh, instead of appending. Oh, it runs the. Oh, the default case gets triggered because it's a number, which is the default case. But yeah, so the problem here, yeah, I see the problem. It's we're trying to call for on an empty array, we're trying to call the last index. Well, what it should be, if it's more than 0, we do that. Else we should do append. Yeah, we should say nones append that. But that's not the key problem right now. That append that. Oh, nums, yeah. Okay, so it actually, we can, it handles this case, even, with parens, or probably can do that one as well. But we can get back to it. Yeah, what we need to fix. So it handles a lot of, some cases, but it doesn't work with actual, like, the numbers bigger than 9. So multi-digit numbers. So we'll need to fix that, but I'm also curious if this works. It looks like it works. I wonder why the opening bracket works, but we'll see. Let's go through the code just to refresh the mechanics in my mind, so I can understand it better and add the capabilities. And we'll see what we can do within an hour. So we get a character. If it's space, we just pass. If it's an open paren, we also pass, which is kind of weird. But let's just. So what will happen is then if it's an operation, we append it onto our operation stack. And if it's but let me, before we get to the close paren, let me go through the default example, which is if it's a number. So it could be either this or a number, and if it's in this case it's just digit, but if it's a digit, what it does, it takes that digit, number b, and takes the operation takes the last operation from the stack. But wait a second. Let me start here. Let me go back. Okay. If it's a number and there is nothing on the operation stack yet, what we actually do, we just add that number to the num stack. So we stack up the numbers. Well, it's going to be just one number. Then the operation will be stacked, and we get another number, and then there is something on the operations. There is an operation to do, so we'll do the operation. That's what it will do. It will take that new number, read that operation on the top of the stack, read this. It will read number. If there is some number, yeah, it will read the number from the stack, and it will call the add function. So do this operation to A and B, and it will assign it to the either the top of the stack if there's something, or just put it on the stack. Okay, we could just pop it and then put it and push it back, append it back. That's what we can do also. If it's 0, if it's 0, if it's not 0, well, we could read. It's okay. The problem right now is not that. So basically, yeah, if we just see number operation, and an operation, it just does that. Yeah, how it handles -1 is kind of it's how this add function works. And we actually assign A as a 0 by default. So if A is never there, like stack is empty, so A is the A number is just going to be 0. So we'll send a 0 here, and we'll send this minus and then like whatever minus number, and it will return 0 minus number, which will be minus number, which is right. I need some water. So this part can add the numbers. Yeah. And it's all good. Even after an open bracket, that's what should be happening until we hit a closed bracket. When we reach... So this will be happening to any, like it will start with a number, we'll get the result of that, we'll get the result of that, and whatnot. But yeah, what will happen here, we'll get the result. So 1 will be plus, we'll have 1 on the stack of numbers, plus on the stack of ops, and then we'll skip the opening bracket, and then we'll have another number. And that number will be processed, which is wrong. Yeah, so that's the problem. Yeah, it shouldn't be working because we need to fix this opening bracket thing. Yeah, the opening bracket means don't do the previous ops. Start don't do the previous op. Just do the next. Append that number like there is nothing there is nothing. Yeah. Start over in some sense. For example, because if we change that test case and we have a minus, it will not work. It should not be working because we'll do it wrong. Yep. Because it's just rolls through these without, consideration. Whatever. I see a bracket, I don't care. So this code right now doesn't care about brackets. So that's another problem. And we now have two sub-problems. One of them is, is this open bracket. Need fix here. And another one is numbers. Need to handle multi-digit numbers. Yeah, and that is a lot. That adds some. I want to fix this before I go there for some reason. I want to fix this. The way this closed bracket works now, when there is a closed paren, yeah, and there is something on the ops, we are essentially so in the idea, what should be happening when there is an open paren, we start a new expression. Sum. Yeah, we start a new sum, and that sum will be done when the signal is when there is a closed paren, and at that point we can we're done with these parens. We can calculate the sum for the previous for the number before it, and and this whole expression, sum of this. The quick solution I'm thinking of, like, I don't know, the cut corner solution is why don't we just append on the nums? Why don't we append on the nums 0 a dummy, essentially a dummy number that will take, when we actually hit the 4, we'll be doing with the dummy we'll be adding all that to the dummy. We also need an operation because when we will hit that next number, this operation will be called. So we'll have like 0 plus 4. The problem is, what if 4 has a minus? What is it? What if it's a signed number? Then we'll have 0 plus minus. So this plus but we need to have it. But that plus will be redundant. So minus 4 the operation for 4 will be minus. So it will be like, it will be essentially, where are my test cases? It will be 0 plus. So it's not gonna change, but it will start accumulating that next sum. Initiating new sum, everything will be added to this, to the 0. And once we hit the paren, what the closed paren, what it does, it takes the number from the stack, like the last number which was on the stack, takes the operation from ops and takes the adds and takes the previous number before that. So it pops numbers twice. A and B both are on the stack, which is, yeah, because it expects to have some second next sum. So if we use 0 for that, that is fine, as long as there is nothing, as long as 4 is not like that. Yeah, so, but if we just put 0, if we don't put, if we use 0, it's fine, but if we put also the operation, then there will be a redundant operation. It's redundant plus, which will affect previous operations, mess up the previous ones. Yeah, because they're all in order. So that's a problem. And it specifically said that 0 could be used as a unary operation. Yeah, so you could have that. So yeah, it's not the right solution. That's what I mean. You essentially need to start over. Yeah, that's why I'm always like thinking, if 30 minutes into this, I'm thinking about the recursive approach, like to start clean, start over. Have that whole thing be working on a new expression, and once it's done, return it. I like it. Yeah, I like how it could be very nice, very, very pretty. So there are, yeah, so the dummy 0, if we just put, yeah, if we put 0, we need an operation here, some operation, but we don't know what it is. If it's 4 plus 4, it's like, there's nothing, but yeah. So the dummy is not really, it's gonna be, it's not gonna work. Yeah, so we need a different approach. What could it be? It could be actually stacking up those params. That's one way. Because yeah, what we need to do once we see a param, we need to start. But I'm thinking, like, why do we really need to? Because this, to store that open param, because essentially we just need to restart. And then once we have that sum, we have the closed param will tell us, okay, have that sum, and which is on top of stack, do the operation, the previous operation to the previous number. It's pretty simple. I don't think we really need to store that param. Yeah, we just need to organize the code. to have the code. Yeah, we can't just skip it because that part, that default that deals with the nums, it will it will not know we're starting over. And also, when I'm thinking about recursive solutions, I don't know if we need a stack. Well, recursion in itself is a call stack. So we have a call for like this parens. Then we see another paren, we start a new call. When we have the close paren, we return that thing. And then continue working in that stack. If there's another nested parens, then it will call do another call. So the call will stop at a closed paren and return a number. It could be a pretty clean solution. I'm thinking about like instinctively, I want to try this. By the way, do we actually need a stack for it? Because this call will have its context, will store the context, and once we have that, so this upper call is our like the highest. Yeah, it could be a good. I think the stack could be a good, nice, pretty solution. I want to simplify this, because it's already there is some repetition here, and it's getting a little bit messy. I want to, if we have each call deal with only within like one math expression without the parens, that it could be a bit cleaner. Could be a bit cleaner. Why? Because you just do the math. It's pretty straightforward math. You only need to take care of this initial possibility of this leading minus, and then you just have the math. You just return that. Yeah, you return that. I wonder how I would do that. Like recursive, recursive what it would look like. So we will need, when we call this, when we go over for I range S, and when we go if, in case this S Si is, if it's an open bracket, then we call another calculate. Let's just use this one, and we pass the we slice S, and we started with I plus 1, because we don't need this open bracket. I plus 1 and the rest. So so the next one will get this, and if the base case is if that is a closed bracket. Well, wait a second. The base case is when the thing is we need to pass. Well, each of these calls need to receive the string, substring, and it needs to return a number. So the deepest call will reach its closed bracket. This, for example, this one. It will reach the closed bracket and return a number. Yeah. And by the way, like there might be some crazy recursion about like whatever about each, I don't know, small part of the expression, but we don't want to make it like the stack too high. So also, hopefully it's not like, this 100,000. Yeah, but I mean, we do when to return when we hit a closed bracket. That's when this call should return. So each call should create its sum. Sum is a 0, and it will go over the nonce, build the sum. We'll do that in a second, but eventually when this is a closed bracket, we should return a sum. It's probably going to be a separate function, which will do just calculate expression. But if it sees an open bracket, it just tells like, just go and calculate this thing. And whatever you bring back, I'm gonna add it to the sum. That's what like should happen. So on every, and it will do it until like the bottom of this nesting. Yeah. And each of those calls, like, yeah, there will be a call for whatever. There will be like, one will return like, let's say some 4 number, then the other one will return this, let's say like 3 plus 4 plus this 4. The other will do 5 plus this plus 7 plus this 7, which was 7. So, and yeah, so this is based on a stack, but on a call stack. And what I like about it is, yeah, we now need to teach that function just to work with a little more simple subproblem. And by the way, we don't need to pass the sum into that call. By the way. I'm wondering why our base case is not. If there shouldn't be like an open bracket at the end. Yeah, it's not based on the, yeah, all the brackets should be valid. So each call should start with a 0, do its thing, and if there is a, and by the way, there might not be any brackets at all, then there will not be any subcall. So if there is no brackets, we'll just return sum. Yeah. It will do the sum, never do a recursive call, never hit the return on the brackets. Yeah. What if it like in this case, this call will start a new call immediately. So when that happens, it will return some sum to the current sum. So it calculate. I like it. I like this. I like this approach. I like it better because it simplifies the code. Yeah. Simplifies the code. I would say I love it. Because now we have those subproblems. Yeah, and yeah, if that is a so we can do the, yeah, we need to deal with when it's a number, when it's an operation, but that should be easier. Yeah, I mean, all the parentheses dance should be solved by this. Yeah. The parentheses kerfuffle should be solved. This should handle the parentheses kerfuffle. I'll just temporarily we'll move that to notes. I don't know why notes are here, but yeah. So yeah, let's do the recursive. So if we took care of the parens, we just now need to take care of our index operators. And our numbers. Yeah, read the full number and do the operation on it. Move on to the next number. Yeah, read. And this already is a good result because, yeah, we can now just deal with a more basic subproblem. Yeah, this whole stack, call stack, has nothing to do. If it sees a paren, it either returns a result or calls in, or delegates this whole subproblem to a new call. Love it. Okay, now where should we start? The operation or the number reading? Because it could be any. Yeah, when a new expression starts, we could be dealing with any. It could be minus something, or it could be just a number. And I'm thinking, can we do that without a stack? Since we really need just to remember one operation, and we actually only remember one number, I don't think we need a stack. We just need to remember the, like, I guess, I mean, what are the cases? There is like n plus n. There is minus n. Yeah. And then something. Or what we also could do is we could imagine that there is essentially it's that. Yeah. So when we see a number, we just add it to the sum. So let's start with a case that it's so we will be building we'll be building a number, one character at a time, one number, one by one. That's the thing. So that's a subproblem, and the sign in front of it, and the sign will be part of it. So what we need when we are here, yeah, we need a num, which will be 0. And we will say if we have a minus, so we come and we see a minus. The op is la 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 la. So we are reading. We are reading it, and the operation is the operation is byte value. We don't have to remember the byte value. Well, we can say it's a function that the operation is a function well, we can use I'm trying to, we need to remember the operation. Just need to remember it, to use it once we build the number. If number is 0, and then once we use it, we'll clean it. We'll delete it, clear it, So we need to build our next, because the result of this will be once we hit what we could do is once we hit if it's a number, if s I think it's Unicode. Unicode is number, but I think the Unicode is number uses runes instead of bytes. Calling Unicode is number. I'm pretty sure it. Well, is digit also read runes, whether the rune is a decimal digit. But is number, we need to turn it into a rune. Or here is an easier way. We'll use v. So v. Oh, I need an I. Yeah. So yeah, because the for the recursion, if Unicode v, yeah. So if it's a number, then we'll append it onto our number, and but here is the deal. Here is the deal. In this subproblem, we'll have several states where the number will begin. So digits. Yeah, when we start a number, let's say it's like, I don't know, we started, it's like 1, 2, the number is 1, 2, 3. The number was empty. We just started. So that's one state. That's a new number. Yeah, and then when we're finished, how do we know we're finished? We have something else, and that could be a closed paren, by the way. That could be a closed paren. So we need that number reader thing. We need to read that number. We can't just say, okay, we need to say that num, because yeah, the first one will be the highest digit, so it will be, we need to say that this v minus which is its integer, the integer of that, these are rooms, we need to multiply by 10, and that we need to add sum plus that. So, but actually, no, we don't need to multiply it by 10. We need to say that sum is sum multiplied by 10. Yeah, we first need to, yeah, if it was like 1 and we're adding 2, we need to 10 plus 2. Yeah. If it was 0, we're just going to have 1. Yeah. So the last one is not going to be multiplied by 10. Yeah. Yeah, so that will build our number, but as long as we are, so we'll have 1, 2, 3. So 123, that will build it. But then we'll need to, yeah, that's our number builder. Yeah. So now this algorithm can, when it gets it, yeah, so it will build it, but essentially, sign. Okay, let's first, okay, let's simplify. Let's first handle the situation when Actually, it's not simplifying. I mean, it would be easier if there was a operation before every number. Yeah, it would be easier. So another subproblem is to read the operation. Yeah. So we go and we see, we assign, we need to, yeah, we need to, essentially we just have two operations, plus and minus. So if it's minus, then we say minus is true. Then we build our number. And then our number at some point. Yeah, there's also another case, which is v is, and yeah, this really calls for a switch. I like switch cases. Switch v. Can we use switch v? Probably can. Because yeah, so case, there will be case space, in which case we just skip. Case case close bracket calls for, yeah, but that's anything that's not a number. Here is the deal. Anything that's not a number means we need to do the operation. Okay? So if there is a number present, we need to do the op. That's the thing. So if, yeah, the general case is if it's not a number and the num is more than 0, we need to say sum. Then we need to do the operation, yeah. If minus, say sum minus num, else if it's not a minus, sum plus equals num. And by the way, yeah, we are in our second hour, but yeah, but I'm still, I mean, it's getting, yeah, I'll clean it up, but I'm so glad we're using recursion here to deal with parens, because it's, yeah, it takes so much complexity out of it. Well, not too much, but quite some substantial amount of complexity. Now we can focus on this, yeah. So if there is a word, or there is a number, and what we have is not a number right now, looking at, it's something else, whatever it is. We need to do the operation before we do anything else. That's the first thing. Yeah. Yeah, so this, we added these things. So we have some number, and yep. Now Yeah, if the minus was not there, then yeah, just add that number. That means there was a plus, or yeah, by default. Now we have the else case. So wait a second. Yeah, but wait a second. So this is not a number. All right. This is not a number. The else case would be it is a number, by the way. Oh, not only. It's if it's not a number and num is empty. That means we don't have a number yet. Well, yeah, if it's well, there is nothing to like to. So this is our operation case, essentially. Yeah, we'll do the operation here. Okay, then we can do this switch case, which handles yeah, it handles everything else. Well, essentially, it is a number. We can take this case separately. Like, yeah, if it's a number, and by the way, is how to spell minus? I don't know how to spell minus. Yeah, the subtraction. Yeah, that's how you spell minus. Yeah, after we did that, we need to say num is 0 and minus is false. Yeah, we need to reset these two. Wonderful. And by the way, we still need to process that value that we got. Yeah. But what if it's a number? Well, we do need to add it to our number. Anything else we need to do? Is there anything else we need to do? I'm not sure. This is just adds. This builds the number whenever it sees a number. Whenever it's something else, and we have a number. We do the operation. Whenever it's something else and we don't have a number, happens the rest of it. Okay, so if it's space, we skip. If it's a closed bracket, we return the sum. If if it's open bracket, we do the recursive call. Yeah, get me the sum of everything in that, in the rest of it. One little problem. Once it gets us that, we'll continue. Yeah, it gets us at the next bracket, but the I will be still here. Yeah, I mean, we'll go to 4, but we'll continue going to 4. We need the I to be updated, so we need that. We need new location for the I. We need to start. Yeah, that's a little problem with using this specific function. Yeah, we need to continue to pick up late after the. Yeah, when the return happens, it should return us the number, and we should continue. So we will, yeah, we will process that number. And by the way, that should trigger. Yeah. Oh yeah. So it does. Yeah. So it does the thing. Yeah. We can. Yeah. We don't have to do anything else. But with the only problem, we need to get to that position. Yeah. I needs to move. I needs to move. How do we do that? In the next call will receive a the next call will get I plus 1, so it will get this I, this index, and we need that call to update the index as well. How can we do that? We could do that if we, I don't know, if we have this index I defined here and not here, and after each loop I plus plus, so each of these functions, each function will determine its own I. No, it's not going to work. We'll declare its own. Yeah, we need that outside. I mean, I don't know how to solve this right now. I need to think. Yeah, I need to think how to either to return the new I, or pass the thing by pointer, because we need that pointer to be updated. That's what we want to happen. because otherwise this function will continue. Yeah, so this open bracket gets us the sum, and there is another case, the op. Yeah, the operation case. So case minus is true. Case plus. Do we need to do anything with the plus? Yes, for a plus, we don't have to do anything. All right. Because by default, we do the plus. Yeah, if it's a plus, we just skip until we get the number. And what will happen here? So 1, then we'll read that. The plus will be ignored, and this will be called. And the sum will be plus. What if it was minus? Well, then we need to do some, it depends on the, so, we need to get that thing, and this. I don't know what, subsum. Nested in parenthesis sum, nested whatever we call it, subsum, and then we'll just do that. Yeah, if minus, we do minus, and yeah. So this is calculated, and then it's either deducted or added. Yeah. So that happens, and yeah, the only problem right now I see is this: when this is returned, our pointer, will continue doing that thing. Doing that, we need to skip that. When that returns, we want to continue with I plus 1 also. So, but that means we need to return to this previous call, this new pointer. Not only the sum, but also the pointer, or we need to pass the slice by pointer. So in all those recursive calls that string well, we need to convert it into a slice and then well, string is a slice of byte. So if we might need just to pass the string by pointer. Is it? Oh no. Oh no. It might be becoming new because the string is immutable. It's a new string. If we reslice it, it's a new string. Yeah. Yeah. So the string is read only, but yeah. So when you pass, we pass the new one. So yeah, if we pass the pointer to our slice, so and each call will reslice it. Oh, each call reslices it to the next. It's not only moving the point. It doesn't change. You see, it doesn't change that slice. So you clean up a little bit so that it's like that it fits the page. Yeah, I mean, where do we want to do our recursion to happen? That's keep, that's return. But some is not enough to return. Yeah, it's so, I like the idea, but we're missing something. We need one more thing here. By the way, can we not repeat that thing? That's our like operation. Well, when we get num is update, num is reset, and minus is reset. Yeah, so minus is also after that. Yeah, it's reset. So it's really a repeating operation. This happens when there is no num. And the only difference is this also requires to, well, we could also say that this is, the num is that. Yeah, the difference is that's, by the way, that's the num, yeah. And num is 0 after that. Yeah, where this num comes from. So this calls for recursion, and then it's really the same operation. We can even like abstract it away, I don't know, to somehow, I don't know what exactly, how exactly, but if, well, this is a case when that v is not a number, anything, and when the number exists. So when v is anything but a number, yeah, whatever it is. There shouldn't be any spaces between the digits, right? Right. Will be no two consecutive operators in the input. So when there is a space, yeah, I hope not, but I hope the spaces only happen like that, but not inside a number. But yeah, so this optimization, we can work on it. That's actually the number. It's actually the sub, yeah, but yeah, we can try and reuse this code. The common here is that it's it's not a number here. Yeah, but other things are different. Yeah, we could move it. Yeah, I think we could move it. Like we could say if it's not a number, yeah, if it's not a number, that's one condition. Then if the number is full, oops. Oh, so we have a number. Then we do that. If it's not a number, so yeah, if if we have a number, yeah, all that happens essentially anyways. This needs to happen. Another case is if v is closed, open bracket, open paren, then so in both of these, that needs to happen. The difference is if v is an open, we need to run this first. Yeah, we need to get the num first. So that's the difference. We need to do the recursive case. Wow, we're into we're well into the second hour. I think this is a minor thing here right now. And I don't know if we can refactor it in some clear way. I don't see it right now. So essentially, if it's so if it's not a number, if we don't do this unless it's an open bracket or that. So we have to have either of that first of all. So and it's either this or that. Either we have a num or we have an open bracket. Or we have an open bracket. And now, okay, now we can structure it. We can do it. I guess we can do it, yeah. Now so in any of these cases, we do the operation is we either have a number or we'll get a number from the brackets. And we just, do we need to get a number? Yeah, we go get a number and then we add it and then we're good. So we can remove that case from here. Okay. Now that's shorter. The only problem left is how do we move it? I mean, the easy approach would be just to move move this into a helper function, which will return the new index. The new index. So which needs to return the sum plus, where should we go next? Where should we continue? Because I mean, in the perfect world, we would cut the slice to the end of this paren and just give that part of that string to this recursive call. Oh no, we can't. This recursive call needs to continue working on it and it might be more. There might be more nested, like thousands of nested parens. So so we don't want to do that. But when the last one happens, it should tell the previous one, like, okay, I did it until this. So I did it until this. So you don't need to do that anymore. Yeah, you continue from here. And right now it will not do that. It will just, got the sum from this nested these nested parens, whatever they were. And now I'll just continue with that. So this call, like this initial call, it starts and this call should return until here. Like it should return the sum, and the next I should be actually it should be here. Yeah, but I don't know how to do it. I'm not sure I see how to do it. I'm not sure. I need to think about it. There is probably, I'm pretty sure there is some simple way to do this. But I mean, how can you do it? Because you need to do all those nasty things, all the nesting. Because like here we start, okay, we delegate that thing, then that one will delegate that thing, and each of them, this inner one should return and say, okay, that last paren was here. Yeah. That closing paren was here. Yeah. And only the last call knows it. Well, the last call will know the most, the lowest nested. Yeah, the lowest nested one. This what could we do? Because I mean, let's just let go of the need to do it in this one root function. I like to do things with just one function, but we don't have to do it at all. So let's do a with a helper function. How would we solve it? The helper function would, by the way, right now this call starts a sum, a num, the sign, goes over the string that we passed and returns the sum. Pretty straightforward. Pretty. String. We need to return not only the sum, but also the position for the I. The latest position. Yeah, it will be the latest call, so whatever the nested were. Like this will be our first recursive call will start with this. and eventually it will stop here and return. And so how can we get it to our root call? Like it had that string, it was working on the string in its own life. So the string was, I'm just using my notebook here. Yeah, the string was something like that initially. And then in the next call, it will be minus with that. The next call will be that. And yeah, this root call, all it will know is, okay, this is my subsum. Yeah, this is the sum inside. This is the subsum, but I don't even know of which part this subsum is, because I only see like this open, and you give me sum. Okay, I gave you this. I gave you the substring of that. Essentially, the substring that I sent is that. And yeah, the next one will called oh no. Next one we'll call this. I mean, yeah, so if we look at this example, it will be like that. You know, this is our first call input. The next call will call 1, then call 2 will have that. Then there will be call 3 nested, which will have, yeah, we'll go through like 1 plus, it will see that thing and it will pass that. And it will go through and it will return the sum of, it will, when it sees that, it will return the sum. This call will have like this 1 and it will have that sum, and it should continue from here, but it's not going to, as same it's as this one is. It made the call here, but it was standing like here. It will continue with 1. So it will have the sum and just add it to 1. And that sum will also have problems, because that sum will go like, okay, I have one, one. This will like repeat everything. It's a good sub problem. So yeah, if with the helper, well, with the helper function, how should it signal what it could do? It could return the string, the rest of the string. Yeah, like this one could say, okay, well, this one will call, we'll call this. This one will say, I came here, so here is the rest of it. This one will get the rest of it and say, okay, I got your sum and here is the rest of it. Yeah, so this root call will have this rest. It will have the result of the sum and then this rest to work with. Yeah, how can we can probably do that. So it needs to return a string, or if we are working on a slice, and we need to go because the office is closing. But yeah, this is like we're well into the second hour, almost in the third hour.
Lock it up.
Sure. And so our security is asking us to have some rest to vacate the office. So I think I'll probably, I don't know, I'll fix it out, maybe do a part 3, but that's an interesting problem. I like how it's going. I want to fix this thing. The other option, yeah, so there are ways to do it. And anyways, thank you for watching. We'll see you in the next videos.